So we are going to look at the various process variables now. So the first one that we are going to look at is the pressure. Okay, pressure, as you well know, is defined as the force per unit area. The force exerted by fluid, either gaseous or liquid, okay, on the walls of the containing vessel. So that is the force per unit area, okay? That is pressure. So as you can see also, pressure is have different units, okay, of measurement. We have the PSI, or pounds per square inch. We have the Pascal, okay. We have the Newton per meter square, Newton for force, meter square for area. Then we have the inch or centimeter of mercury, centimeter of water or of mercury, okay, or millimeters of mercury, millimeters of water, okay. Then we have the atmospheric pressure, ATM, okay. Then we have the torr, and also we have the bar, which is about 1.013 atm. Okay, that is atmospheric pressure, and that is equal to about 100 kilopascal in the metric system. So these are the various units, okay, that are used to represent this process variable pressure. Are we getting it? So we are going to see this pressure, what are the various sensors that could be used to monitor this pressure, and how these sensors monitor or help to monitor the pressure, okay? So that is what we'll be looking at. So pressure measurement, we need pressure sensors to measure the pressure in our process, okay? So as you can see now, this is our process. The sensor is down there looking at the process, okay, which means that the sensor is exposed directly to the process, and it is by means of that sensor that we are getting the pressure reading, okay. So we have different types of sensors for pressure. We have the pressure manometer, we have the Bourdon tube. We'll explain them in a little detail later. We have the diaphragm, we have the capsules, and we have the bellows, okay? And then we have the strain gauge. These are sensors that could be used to monitor pressure, or look at the pressure in our process. So let us look at the first one, which is the pressure manometer. So the pressure manometer is one of the simplest pressure sensor, okay. It's just having a U-tube, both end open, and then subjected to the different pressures. Are we getting it? So like in the one we have on the left now, you see that the U-tube, assuming you have water or whatever fluid on it, both ends they are open to the atmosphere, okay, which means that the both ends they are subjected to atmospheric pressure, the same amount of pressure. So the force on this water column is equal to the force on this water column, okay. So which means that the level on each side of the tube will be the same. It is balanced. So that is why we have it here at the 0 point, okay. So it is calibrated to give us 0. So now assume that this end of it is now connected to a pressure source. Are we getting it? So which means that if that pressure source is higher than the atmospheric pressure, what will happen? You see that the force on this column will be higher, and that will move the fluid in the right column up. Okay, so it will move it up to a stage where the height above the left column is exactly equivalent to the force that is exerted on the left column. Okay, so that is how the pressure manometer work. So if you look at it, you will see that the water on the right have been displaced. Okay, then the distance between here and here is about 2 units. Are we getting it? So that could be calibrated to give us the direct reading of the pressure. So if each of these is an ATM, 1 atmosphere, it means that we have almost 2 atmosphere here. That will be equal to the pressure of the fluid that this end of the manometer is subjected to. Okay, so we also have the Bourdon tube. The Bourdon tube is just a tube that is capable of expansion when the pressure, internal pressure is increased. Okay, so what this means is that there is an opening here that goes into this tube. So once the pressure is administered into the tube, you see that it has the effect of elongating this tube, stretching this tube. So as this tube is stretched, since it is connected to the spindle, you see that the spindle will move. And this scale have been calibrated, okay, to give us the pressure reading that will be responsible for that specific movement on the scale. So this is how it looks physically, the Bourdon tube. This is the opening that is connected to the process, this part of it. So as the pressure increases, okay, this Bourdon tube will stretch. As it stretches, this spindle will be moved. And remember, we have the scale here, as you can see on this on the far right of your screen. Okay, so as the pressure is increasing, you see the tube is stretching out, and as it's stretching, the spindle will move to register the the pressure, okay, that is responsible for that stretch. Then as the pressure also reduces, you see it falling back. Are we getting it? So this is the Bourdon tube, how it works. It's a very simple pressure sensor. Very simple and very reliable. Okay, pressure sensor. So this is also the Bourdon tube, and then we have it on the gauge already. Okay, so the Bourdon tube is inside of this gauge, and then we see the calibrated scale. Are we getting it? So the range of this particular meter is about 10 bar. Okay, so as the pressure is increasing, the Bourdon tube is stretched. This will now be moved, okay, to register the pressure that we have on the process. So it's a very simple but reliable pressure sensor that we often use in our process. So the other one that we are going to be looking at, or ones that we are going to be looking at, are the diaphragms, the capsules, and the bellows. Okay, so the diaphragm, basically they are made up of a very light membrane that is capable of stretching, okay, when subjected to high pressure. It's just like the diaphragm that is separating the thorax from the abdomen in humans. Okay, as you increase the pressure in your thorax, that is in your lung, the diaphragm will stretch. Okay, it also uses the same principle. So as you can see here, as the pressure This part of it is exposed to the process. As the pressure increases, it stretches the diaphragm. Okay, as it stretches the diaphragm, that diaphragm movement is now transmitted into this element, okay, that will eventually cause the movement of this spindle. Are we getting it like we saw earlier? But instead of the process fluid directly affecting the stretching, it is this element, okay, that got its movement from the diaphragm. So if it stretches, it moves up. Once it's collapsing, it moves down. That is what we are seeing here, okay. So as the pressure is increasing, it stretches, moves up, okay. As the pressure is reducing, it collapses, move down, and then that will affect the movement of the spindle on the gauge. So we also have the capsule. The capsule is like two diaphragm, okay, one on top the other. Are we getting it? As you can see on your screen, this is one diaphragm, this is another diaphragm. Have the edges sealed, okay. One part, the lower part of it or one part of it is exposed, have an opening that is exposed to your process. Then the other part is attached to a lever or something that will carry the movement of the upper diaphragm, okay, to your gauge, as we saw in the case of this diaphragm, this capillary, okay, that drives it. Could be fluid also. Are we getting it? Fluid could be contained here. So as this one is stretching, it increases the pressure here, and that fluid can transmit the pressure to this part of it. Could also be a Bourdon tube that can cause the stretching here, okay. So here we have two of such diaphragm. So as the pressure increases, the diaphragm, the capsule is inflated, okay, and then as it's inflated, it rises, as we saw the other time. You see, it rises, and then it moves the spindle on the indicator, as we saw in the case of the diaphragm, okay. So once the pressure in the capsule has increased, you see this movement here. The spindle is attached on the indicator, okay, and then that gives us or register the pressure. So the capsule is another very simple pressure sensor. So we have the here, as you can see, pressure. This is the capsule, stretches, okay, and then this the mechanical or mechanism, and here we have the dial in the front, and then we have this is the gauge, so to say. This is what we are discussing, okay. So we have the capsule here, then the capillary that sends the movement of the capsule to the gauge, okay, and then as the gauge moves, it registers the pressure that is exerted in the capsule. So we have the bellow. As you can see, the bellow is just like a convoluted structure, okay, that is capable of expanding once it is a pressure is exerted to the internals of the bellow. That is what you are seeing here. So as pressure is exerted, you see it stretches, okay, it opens up, stretches out. So and then since we have the spindle attached to this lever that is attached to the bellow, so as the pressure increases, it moves up, and that is registered on the spindle. That is what we have here too, okay. So the pressure increases, stretches the bellow. That bellow movement is transmitted to the movement of this spindle, and thus we have the pressure on the line registered on the pressure. So these are very simple pressure sensors. Okay. So we have another